This is Dr. Carroll, and this video is about generic methods. These are really cool because what they allow us to do is to really utilize code and reuse it in an intelligent and extendable manner. So we could call these function templates, and what they do is they allow us to reuse the code. You could think an algorithm for many different data types. So let's see an example here. Let's say you wanted to write a method like a print array method that prints out all of the elements in an array of integers. Okay, well, we verify that the length is at least 0, there's at least one element in there printed out, and then for all of the rest of the elements we print a comma and then its element and then a new line. Well, that's great, we put commas in front, and so we have a more intelligent display now. And so your boss is so happy with this, he said, great, now I want one for double and char and strings and a whole bunch of others. And you're like, whoa, is there a better way to do this? So in comes generic methods to save the day. And so we could have written, like, this is the same method. Now if we replace, notice what we did. We replaced the type here with E and said, hey, this is a generic type. This is the unspecified type here. We specify that after public or after static if we have static, but before the rest of the signature, before the return value, we say, hey, this has a generic data type here. And then we specify it. So this will work for integers, it will work for doubles, it will work for characters. We can call print array on all of these, and this is what it'll display. It'll put a comma in there in between each of the values, but not at the last one. Well, this is great. Now we have it. And now notice what is interesting is it is determining what is this unspecified data type at compile time. It says, hey, this is an array of characters. Okay, so this E for this instance, this execution is going to be character, or in this case double, or in the first one integer. And there we have it. So it can infer it at compilation time. So the general syntax for generic methods is we have our accessibility modifier, and then we have angle brackets, and then we specify it here, some unspecified type, and then we have our return type, our method name, and then our parameter list, and then we have the rest of the method. So often the unspecified type here will appear in the return type and or the parameter list. And E and T are very commonly used as unspecified data type names. Now, the example shown here, we could have used object, and yes, that would have worked, but it does exhibit using a generic method. Now let's move on to an example that we can't use object. And let's also use that to show using multiple unspecified data types. So the general rule is that they are specified with commas if we have more than one. So let's go to this code here. So here we have a very simple illustration of specifying more than one. Now look how long this line gets here, but don't get lost in the weeds here, lost in the details. So we have our generic types here in the angle brackets highlighted. We have a return type, we have our method name, and then we have the parameter list. And notice we have T1, so our type 1, and we're saying, hey, the first parameter here, it's going to be of type T1, and then we're going to have an int, and then we're going to have a set, we're going to have some object which implements the set interface, and it's going to be templated with type T2. And so, and notice T2 shows up here, we specify that here, and furthermore we're saying T1 is a list that's templated with type T2, or it's a subclass of it. It extends it. So extends here is a little interesting how it's being used, in that it can be a list or it can be one of its children that implements it. Here, notice we have this T2. It's not specified. It's not necessarily a string or an int or whatever. And so we have this item that we were calling get out of the first parameter. Now, the first parameter is, we know it's of type list. It implements list. We're not quite sure exactly which one, but we know it's going to implement the interface list. And then we're going to add it to some set here. We're not sure exactly. It's flexible, and that it could be any type of set. We're going to add that item in there. So let's look at main and how we're calling it. Here I've just set up a string of numbers to populate a vector of strings. Now, vector is very similar to array list. The difference is you can use vector among multiple threads, and array list you shouldn't. So as long as you're not doing multi-threading, general rule is use array list. But here's vector as well. Vector implements the list interface, and it can store strings. And so a lot of the functionality you have with array list, you also have with vector, because array list also implements the list interface. So we're specifying a new vector just like we would array list here. Notice we're templating them both with string. And here we have a set, and it's an interface, so we need to set it with a class. So let's say tree set. We could have used hash set. And so this is a templated class. It's a generic class, and so we're providing the string type here as the unspecified type. We're specifying it as string. So we're just going through this array of numbers to add it to both the integer strings and the double strings here, creating a string, and we'll display those. And now look here, get and add. This is int strings is a generic, is a vector class with the generic type as strings, and we're specifying string set here, and then we're calling the same method, the same generic method with double strings, which is an array list, because they both fit into there. And so we can specify that here, and then we can display that. Let's watch this compile. Woohoo! It compiles, and there we have it. We're displaying it, just asking the vector and the array list to display themselves, and string set did insert them. Now I just want to talk real quick. This is called a bounded generic. We're saying it can't just be any type. It has to be a list or a child, something that implements list, and furthermore, it needs to be storing elements of type T2. So we call that a bounded generic. T1 is a bounded generic. I hope you enjoyed it. That's it for this video. Check out my video on generic classes.